$70 to $80 per board. So we're trying to reduce it down a little bit more, looking to have half the price at around $35. So we actually did modify the current 3D Boosterpack that TVAC has, and that's basically the main part that we have. At this point, the hardware works okay, but we're having some connectivity issue with the firmware. It is basically not recognizing the second and third extruder as independent extruders. So it's sending information to all three at the same time. So it's moving them all at the same time. So that's what our current project goal is working on. The next steps after this is after we measure everything, it's starting to kickstart a campaign, maybe get some tips from actually your friends from the group team on how to actually start a Kickstarter campaign for that. And I know they have a lot of issues, so having their input on those is going to help us all too. So that's basically what we're doing. Any questions that you may have about it?
What's the hardest part that you run into in the project so far?
I'm sorry?
What's the most challenging aspect of the project so far?
The firmware. Basically just manipulating, because we're all EEs, we're not too much into CS majors. So modifying, trying to get information. Sometimes even you post it on blogs, hey, we have this problem into here, and they just tell you, oh yeah, this is the same problem as we had before, but it's not comparable to what they do. Normally they're most supports that actually were getting feedback. There was, well, in our domain we did this, just put it like this way. And sometimes it's not the same thing, but we're using completely different,
How much have you had to coordinate with the other team this semester?
We actually, not too much coordination as well, but we're side by side with each other at the table, so we were measuring our progress as well. Basically what we're going to be doing is whatever results they have, we're going to integrate it to our own. So they can be basically just one big 3D printer using the dual extruder and whatever they develop. But we have to support the extra stepper motor for to add it to integrate as well.
I guess I don't understand the basic objective. You're building a printed circuit board or a 3D printed circuit board?
Our main goal is to build the PCB, right, that controls everything. But the main scope of the whole program.
What are you trying to build? What is this thing build? Not how you implement it. What is the object you're trying to do?
Oh, we're trying to build a small PCB, like a person that has a 3D printer, they can attach that to the Boosterpack that they have and print small PCB boards.
Okay, is this printed circuit board a double-sided board, or is it actually a three-dimensional board?
It's going to be layered. We put a plastic on it, basically a PLA or plastic that they have, and with the help of the extruder, the PACE extruder is going to do the wiring for us. Basically, we're going to be laying the wires into it, and you can put the components manually. That's basically just basic zipper printing.
Excuse me for being so dumb, but how do you lay wires into a...
Using the PACE extruder, it's an injection, it's like a liquid, it's a paste, like more paste to liquid. So having the STL file for whatever layer you want to use is going to be extruding paste into it, and it's copper based, so it's conducted already into it.
So you use two different materials?
Yes, you can actually use 3 different materials. If you have, we can have PLA, we can have a supporting material, the plastic that can be, if you have some supporting stuff, and you need some support, and the extruder as well.
And what are the limitations on your boards? I mean, you do 20 layers, 10 layers?
As much as high as you have, as much as the higher that your 3D printer gets.
So it's as big as your printer.
Yeah.
Okay.
One of the limitations is the width and the height, but that's on your 3D printer.
We've actually been using 3D boards, which is like a piece of plastic that's in 3 dimensions. And you can put like an optical sensor on one side and solder other boards on others. So I mean, there's types of things like that too. Okay.
Yeah, that's what I was going to ask, whether the kind of application you envision is just a planar sort of board or this funny shaped, actually 3D inductive circuit holding things in
The
the
user can be creative with it. It could be any structure. The circuits can be integrated in whatever structure that you use. So however creative you are, you can do that.
How do you handle making the VIA connections?
There's not going to be a VIA by itself, it's layer by layer. So you have a plastic, and you do the wiring by itself, and then you put another one. So that's a limitation that it has. It's not going to be like you're going to go deep into the other one and connect to the other one.
But you can actually implement layers.
You
is by laying